Hi everyone, let's solve today's daily challenge, that is minimum time to complete trips. In this question, we are given a time array in which elements of time array basically denotes the time taken by ith bus to complete one trip. Each bus can make multiple trips successively, that is, the next trip can start immediately after completing the current trip. Also, each bus operates independently, that is, the trips of one bus do not influence the trips of any other bus. Right, you are also given an integer total trips which denotes the number of trips all buses should make in total, and we need to return the minimum time required for all the buses to complete at least total trips of trips. Right, so let's understand what the question means. So basically we are given this time array. So this time array denotes what? It is the time taken by the ith bus to complete one trip, right? So if it is the first bus, right, so first bus takes 1 second to complete the trip, complete a particular trip, and second bus takes 2 seconds, third bus takes 3 seconds. So that is what this time array represents, and then these are the number of trips that is given to us, and we are being asked the minimum number of time to complete at least these many trips, right? And one thing that is given to us is that we can do multiple trips successively, that is, once we have done a trip with this bus, right, after 1 second completes, one trip is done, and just after 1 second we can continue with our second trip, right? And also each bus operates independently, that is, all the buses can travel independently. So if this bus is traveling, it doesn't have any relation to second bus traveling or third bus traveling. That means any bus can travel at any particular time, right? So all the buses are traveling independently. So now let's see the question. So let's consider this first test case only. So we are given time array as 1, 2 and 3, right? And the total number of trips are given to us as 5. We need to do 5 trips, right? And these are the buses given to us. This is the first bus, second bus, third bus, right? So now let's see. So in the question, like, you might also misunderstood the question, and you will try to compute a value with taking the minimum time out of this array, and you will say that if I take the minimum time and if I simply multiply it with the number of trips that is given to us, then I will be getting a minimum time, right? But that will be a wrong answer. Why? Because we are given in the question that the buses can travel independently. That means if the first bus is traveling, we can also make the second bus travel at the same time, right? Simultaneously these all buses can travel together, right? So the scenario will be something like, so let's try to compute the answer second by second as is given in the first test case, right? So we will consider at t is equal to 1. Let's see the scenario, what will be happening, right? So we have the first bus, second bus, third bus, right? So how many trips? Let's write the number of trips here in the form of an array, right? So first bus will be completing one trip, the second bus will not be completing any trip, right? So we will write 0 0 at t is equal to 2. What will be the scenario? Now by t is equal to 2, we are saying that after this bus has traveled, it can immediately start traveling again. So we can say that after 1 second it traveled, and then it again went for another trip. So by t is equal to 2, it would have completed 2 trips, right? Then if you see the second bus, it takes 2 seconds, and we are at t is equal to 2. That means this bus was traveling, and now because t is equal to 2, it has completed 1 trip, right? So we will be getting 1 here. The third bus hasn't completed any trip, but it is traveling. Now at t is equal to 3, what will be the case? The first bus would have done 3 trips, the second bus would have done 1 trip only, and the third bus has also done 1 trip. Now if you see the total number of trips here, so it was 1 at this t is equal to 1 second. So total trips here was 3, right? And total here was 5. So how many trips we needed? We needed 5 trips only, and we needed to compute the time. Now you see at t is equal to 3, right, we have got an answer, right? That is, we have done at least 5 trips, right? But if you would have taken the minimum out of all these and have multiplied with total trips, you will be getting 5 as an answer, right? Which is wrong. So that is why we will not be doing this. So all the buses are traveling simultaneously, right? Now if you see the constraints, what you will try to do is, you will say that, see, the answer will lie within this range, right? That is 1 and 10 raised power 7, right? And we can also decrease this value by saying that if we what we were trying to do, we were considering this particular the minimum element out of all these time array elements, and you were multiplying it with the number of total trips. So you were saying that you were getting an minimum value, but this is not minimum, so we can say that from 1 to this particular value, right, we will obtain an answer, right? That is for sure, right? So you will do what? You will try to iterate in this particular range and you will try to get an answer. Now if you're trying to iterate in a range, right, so you are basically trying to iterate on the answer that you want, right? That is the minimum time. So you are saying that I will iterate in the range 1 to the minimum element, right, into total trips. So you will be iterating here. So you see that this is a range, right, and it will be in ascending order only, right? If it is in ascending order and we are trying to find an answer here, so can we apply binary search here, right? Why should we go with the OFN approach? It will give us TLE. Why can't we go with this approach, that what if we apply binary search here? We can, right? Now let's see how will we reject one part of the array and keep one part of the array. So what we will do in binary search, what do? We calculate a mid, and according to this particular mid value we do some calculation and we check which part of the array we have to reject, right? So where do we have to move, right? Towards the left of the array or towards the right of the array. So we are rejecting one half of the array, right? So one thing is clear, we will be applying binary search. Now let's see what operation we will be applying to know whether this particular answer is minimum or not. So this is our time only, right? So we will be obtaining an answer from this particular range. So what do? We will calculate mid. Now what we will doing is we will be writing a is feasible function, and what this function will be checking is whether this particular mid is a feasible answer or not. And how will we tell if it is a feasible answer or not? Now you want to calculate what? The number of trips. So the number of trips, how will you calculate? For example, in this case you will say the range is between 1 to 5, right? Between 1 to 5. How do you know that? Let's calculate the mid here. So the mid itself is 3 here, right? So which is the answer, but let's try to do it, right? So mid is 3. Now how will you be calculating an answer? What will you do is you will be iterating inside of this time array, right? This particular array, that is 1 to 3. You will be iterating inside of this, and what will you be calculating? Let's take an answer variable here. In answer variable we will be calculating the number of trips, right? So how will you calculate the number of trips? You will take this particular time and you will divide it by the time taken by each bus, right? So what will you do? You will divide this by time of I, right? Basically time taken by each bus, and you will add it to answer, right? And then you will check if this answer comes out to be greater than equal to the total number of trips, then at this point you will be obtaining an answer, right? So this is what we will be doing. So this is the logic for the is feasible function, right? So in this particular function we will be calculating whether our answer that we are trying to whether this particular mid value that we have is a feasible answer or not. If it is feasible, then what we will do? We will reject the right half. We will say that as this is because we want to obtain a minimum value, right? So we are starting from 1 and we are going to a higher range. So if this mid value is possible, then we will move towards the left and we will check whether or not even a lesser value is possible or not, right? So that we will check, and that is why we will move towards the left part of the array. Now if this mid is not feasible, that means our answer lies in the right part of the array. So I hope the way that we will be solving this problem is clear to you, right? Okay, so before we code it out, Newton School is organizing CodeRush March edition, and this contest will start in 15 days. So you can register in this contest. In this contest you will be getting some prizes and internship opportunities. So I will give the link of this in the description, and from there you can register in this contest, right? Now let's move on to the code part, right? So I hope things are clear to you. What we'll be doing, we have calculated this range, right? So we know our answer will be lying in this particular range. So if our answer in this particular range is there, we will be doing binary search on this range. So this problem is basically a binary search on answer kind of problem. So we'll be doing binary search on the answer itself, that is the time we want. So we'll be doing binary search on this range. And how will we checking whether a particular, like what part of the array we have to reject, right? So for that we will be writing this is feasible function, right? If it will tell us the feasibility of the mid value that we have calculated, and it will be responsible for telling us whether or not we have to consider left part or the right part of the array. So let's see it in action now. Let's code it. So first, as I said, what do we want? We want the range. So as we saw, the range will be, so we will be taking everything in long because okay, so start, right? Long start, it is the start, and we will be having a start pointer and an end pointer, right? So start pointer will be pointing to the first element of the range, that is 1, and the end pointer will be pointing at the last index, right? So what was the end pointer? So we said that end pointer will be, end pointer is minimum element of this array into the total trips, right? So we know that our answer will be lying in this particular range only. So we can calculate the minimum element by using the min element function, right? So what we will do is, okay, wait, 1ll, and here we will calculate our min element, right, from time begin time dot end, right, and into total trips, right? Okay, wait, let me increase this size. Okay, and also declare an answer variable here, and let's initialize it to long max because we will be calculating a minimum value, right? Now let's write our binary search. So how do we write it? Start is less than equal to end, we write it this way, and then what do we do? First, what we will do is calculate the mid, right? So how will we calculate the mid? Mid will be equal to start plus end minus this start divided by 2, right? Now after this, we will be checking its feasibility, whether or not this particular mid that we have calculated is feasible or not, right? So this will be a boolean function. It will return a bool value according to this that is answer is greater than equal to total trips or not, right? So first let's complete this binary search, and then we will be writing the logic for this is feasible function. So what do we have to pass here? First of all, we need to pass the array, that is the time, and we need to pass the mid element, and we need to pass the total trips, right? And we will check if this is feasible, that if this it has written true, right? Then what we have to do, we will say that we are getting an answer, right? So we will calculate it here. We'll say that answer comma mid, right? And what we will do, we will say that if this particular mid is possible, right, then that means all the values greater than this mid are also possible, but we want a minimum value. So where will we move? We will be moving towards the left part of the array. So what is the left part of the array? We will say high is equal to mid minus 1. So we'll move towards the left part. Else what we have to do, we have to move towards the right part of the array. So that will be low is equal to mid plus 1, right? Now this is complete, and after we are done with this binary search, we will return the answer, right? Now let's write the logic for the is feasible function. So here we are writing the is feasible function. So first what it takes the time vector, right, time, and it takes the mid. Okay, so make sure you write long here because mid is long, and int total trips, right? So these three values this function will be taking. Now what this function will do is, let's also calculate a long ans here, and let's initialize it to 0. Here we will be calculating in this particular value the number of trips that we will be able to do using this particular mid, right? So how will we get the answer? So as we saw, int I is equal to 0, we will be traversing inside of this time vector, and time dot size and I plus plus. How will we calculate our answer? We will say that this mid, right, whatever time it is, we have to divide it by the individual times the bus takes, right? That is, the first bus takes 1, it takes 2, it takes 3. So we will divide mid by that particular element, right? So we will be getting this, and after we get this, we will simply return whether or not this answer is greater than equal to total trips or not. If it is greater than equal to total trips, that means this is a feasible answer. This particular mid that we have considered is a feasible answer, otherwise it is not. So yeah, this is the whole logic of the problem. So let's quickly run it and see if it works or not. Okay, wait, sorry, this will be end and this will be start. Okay, now run it. So it's accepted. So that is how you have to solve this question. So what we are basically doing is, we are doing binary search on the answer itself, right? So we have kind of tried to compute a range. So that range starts from 1 and it goes to minimum element into that the number of total trips. So we know the answer will be lying in this particular range only, but we need to find a minimum answer. So how are we finding a minimum answer? We are writing this is feasible function. So for each and every time present inside of this range, we are calculating whether or not that time is feasible or not. If it is feasible, then we will be moving towards the left part of the array, and we will be checking whether a minimum time exists or not, and we will be storing it inside of answer, right, whatever the minimum is, and we will simply return it.